Steady state exercise. What is steady state exercise? Steady state exercise is activities where your body can keep up with the demands of oxygen. There is little to no lactic acid or any waste products formed. This is because your body can deliver oxygenated blood to the working muscles. It is a balance between energy required and the rate of oxygen delivered. An example of steady state exercise is jogs, marathons, or anything that requires or usually lasts a long time at a comfortable intensity. On a graph, there is no oxygen debt to pay back. Oxygen debt may come with anaerobic exercise and its build-up of lactic acid, where there is not enough oxygen to get rid of any waste products. Method for the test. First, we weigh all the participants and find out what percentage of their weight is. Then we will add 2% of their weight, so we know what weight to put on the bike. We will then take the heart rate, blood pressure, breathing rate, O2 saturation, and lactate to get resting values before starting the exercise. The participant will do a warm-up on the bike machine with no weight to warm up the muscles that will be used during the 20-minute cycle. They will start cycling with increased weight. Every minute their heart rate will be recorded with a heart rate monitor they will wear on their chest. The O2 saturation levels will also be recorded every minute using the finger clip, which can also give heart rate if the other monitor fails to work. Every 2 minutes the blood pressure will be taken with a blood pressure monitor on the left arm to give values for systolic and diastolic. Also at every 2 minutes breathing rates will be recorded to get a value of breaths per minute. This is done by eye. The RPE, rate of perceived exertion, will be given to the performer to see where they feel they're working at compared to the chart. Lactic saturation values will be recorded before 10 minutes in. And at the end of the test to see if there are levels of lactate in the blood. This will be done through getting a small sample of blood with a small prick. Types of hypothesis. Null. The hypothesis that there is no significant difference between specified populations and any observed difference being due to sampling or experimental error. Two-tailed. A test of statistical hypothesis where the region of rejection is on both sides of the sampling distribution. This is called a two-tailed test. Single-tailed. A one-tailed test is a statistical test in which the critical area of distribution is one-sided so that it's either greater or less than a certain value, but not both. One-tailed test is also known as directional hypothesis or directional test. Hypothesis for breathing rate. The breathing rate can only be measured by technical equipment which we don't have access to. Instead, we can watch the athlete to see how many times they're breathing and out every 5 minutes. His breathing rate will increase and plateau, then decrease slowly. Heart rate. During steady state exercise, the heart rate will increase during the anticipated rise and slightly more during the beginning phase of the exercise. However, the heart rate will eventually stagger and then plateau. Energy system. There are two complex energy systems, anaerobic or aerobic energy systems. They both provide energy for humans to be able to carry out exercise. Aerobic energy system is used for aerobic exercise like jogs. Anaerobic energy system is used for aerobic energy exercise, for example sprints. These most provide for body's ATP. This system provides ATP as energy is released from the breakdowns of nutrients such as glucose and fatty acids. We also have oxygen that can be formed through glycolysis. Stroke volume is the amount of blood pumped out by the left ventricle of the heart in one contraction. The stroke volume is not all blood contained in the left ventricle. Normally only about 2/3 of the blood in the ventricle is expelled with each beat. Otherwise you would die if there's no blood in there. Together with heart rates, the stroke volume determines the output of blood by the heart per minute. During steady state exercise, there is an increase in venous return. Venous return is the rate of blood flow back to the heart. Venous return normally limits cardiac output. Superposition of the cardiac function curve and venous return curve is usually in with the high. The increased amount of blood stretches the cardiac muscle, forcing it out and to pump a lot stronger, meaning more oxygen can be delivered to the working muscles to stop the build-up of lactic acid and to remove chances of building up an oxygen jet. So the stroke volume increases with steady state exercise, and this is also recorded as Stalin's law. Here as you can see on the graph is the difference between a trained and untrained human. We can see that the elite athlete is more efficient and can pump out more blood per beat. When they are both working at 200 beats per minute, the athlete's stroke volumes reach 180 milliliters, meaning that more oxygen is getting to the working muscles, meaning that the athlete can go longer without fatigue and work at a faster rate. On the other hand, the untrained athlete is at 200 beats per minute and is reaching 125 milliliters. This means they will fatigue a lot quicker and slow down because lactic acid will start to build up, and this just slows them down because it's a waste product. Heart rate. The definition of heart rate is the number of heartbeats per unit of time, usually per minute. Before steady state exercise, a human will anticipate the anticipated rise. This is a slight increase of heart rate to prepare. What it is there's a release of adrenaline from the adrenal gland, and that increases the heart rate in your body, getting yourself ready for exercise. You'll be working at 60 to 70% of your maximal heart. However, the heart rate will eventually stagger and then plateau. Regular steady state exercise can result in a decrease in the resting heart rate. This is the lower someone's heart rate is, the better, because the more blood they can pump around per beat. The more steady state exercise someone does, the more efficient the heart will become. This means their nervous system will be able to communicate to the SA node, allowing the human to pump out more blood per beat. The slower the heart rate, the better. The thermal receptors detect heat and send a message to the cardiac control system in the stem of the brain. This then sends a message to the SA node down the sympathetic nerve, and the stimulates the release of adrenal from the adrenal gland, and that rises the heart rate. Cardiac output. Definition of cardiac output: the volume of blood ejected from the left side of the heart in 1 minute. Steady state aerobic exercise makes the body increase the amount of blood pumped out by heart. Cardiac output is determined by stroke volume and heart rate. So it's stroke volume times heart rate will give you cardiac output. Stroke volume is the amount of blood pumped with each heartbeat. If you do steady state exercise for long enough, it will result in more capillaries and better capillaries and open the existing ones more. This means that your blood will flow better and the return to the heart will be more effective than someone who doesn't do steady state exercise. This also increases the body's ability to deliver oxygen and important nutrients. Also, it's important for the removal of any waste products. The stroke volume would be a little bit more than 70 milliliters, but of course it changes dramatic as a person begins to exercise. That's just the average amount. Breathing rate. Before steady state exercise, a human body will experience the anticipated rise. Because the client is thinking about doing the exercise, they will breathe in deeper, as this is classed as volitional control. Volitional control is just a thought or process that stimulates the heart rate to increase. Volitional or will is a cognitive process by an individual decides on committing to a course of action. It is defined as a purpose, striving, and is one of the primary human psychological functions. Volitional process can be applied consciously, or they can be automatic as habits over time. A message gets sent to the RCC in the medulla oblongata, which is in the stem of the brain. This then sends a message down the sympathetic nerve, down into the intercostal muscles, and that stimulates the increase of the breathing rate. During steady state exercise, your breathing rate will increase, but as the body can meet the demands of the oxygen, it will plateau, meaning that it should stay around the same area for most of it, but it will eventually drop off quickly as there is no oxygen depth to clear. Athletes' tidal volume will increase. However, breathing rate will only increase by a small amount. Deeper breathing causes a more amount of tidal volume to enter the alveoli. This means when the athlete are performing steady state exercise, they can get alveolar ventriculation, which can increase. They get more oxygen to the working muscles, which gets rid of the waste products, allowing them to run further and at a quicker pace. As there is a high demand for oxygen in our muscles there's a higher demand for oxygen in our muscles when we're exercising. The internal and external respiration increase. This process is oxygen hemoglobin dislocation curve. This is explained in the next slide. Oxygen dislocation curve is graphic expression of affinity of hemoglobin for oxygen as functional of the partial pressure of oxygen. Dislocation is influenced by the pH, which is the acidity level in blood, the temperature and carbon dioxide pressure. Most oxygen is transported in the blood by the hemoglobin. A reaction happens with oxygen and the hemoglobin, and this makes oxyhemoglobin. This reaction is only temporary and can be reversed. So this means that oxygen can be separated from the hemoglobin if necessary. The binding of the oxygen and hemoglobin The binding of oxygen and hemoglobin depends on the partial pressure of oxygen. At different altitudes there is different pressure in oxygen. For example, when you're climbing a mountain there will be a lot less oxygen with a higher pressure. This makes it harder for someone to breathe because they can't get the same amount of oxygen in as they would do at ground level. Oxygen binds with the hemoglobin in the lungs because this is a rich place where there's lots of rich in oxygen place. Where there is a change in blood carbon level, it causes a shift in the oxygen dislocation curve. These shifts make the oxygen release and this increase intake of oxygen in the lungs, which obviously we need in steady state exercise to meet the demands of the activity. However, we do steady state exercise like a jog. Our bodies can meet the oxygen demands of exercise, resulting in little carbon dioxide. Therefore, there isn't a big increase in the oxygen dislocation curve. Golgi tendon organ and muscle spindle. Golgi tendon organs are receptors that are activated by stretch or contraction of a muscle, and that sends information about the muscle tension. It's a proprioceptive sensor receptor organ which senses change in muscle tension. It lies at the origin and insertion of the skeletal muscle fibers into the tendon of the skeletal muscle. The tendon sends information to the central nervous system that is defined as the complex of nerve tissues that controls activity of the body. The central nervous system then decides how many motor units to contract to create smooth muscle movement. The more your body does steady state exercise, the more efficient the muscle spindles are at transmitting this information. In the vertebrae, it compresses the brain and the spinal cord. Golgi tendons and muscle spindles facilitate smooth movement patterns. Heat is a factor that increases the speed of transmission involving the nerve impulse. Muscle spindles are stretch receptors within the body of a muscle that primarily detects change in the length of the muscle. They convey length information to the central nervous system via the afferent nerve fiber.